What DESY provides scientists with is a photon source. Our photon source is Petra 3, that's a 2.3 kilometer ring, which produces a huge amount of X-rays. X-ray crystallography means taking X-rays and crystals, putting them together. You take the crystals, fire X-rays through them, they diffract, which means they deviate, and then they hit a detector, producing a pattern which is a set of dots. You repeat this process again and again on the crystal. What you end up with is a whole set of images, thousands and thousands of images. They're basically just black with dots. Now, the separation of the dots and the intensities of the dots, if you then take that back, you can work out the structure of whatever it was that the X-rays hit. And that something is either a virus, which is extremely dangerous, it is a protein which may have deformations, and the whole thing is an iterative process. One of our biggest challenges is we have 5 gigabytes per second coming into the computer center from several different places, and we can't lose any of this data. This is extremely precious data.
We had 10 months to put everything in place, so we worked together with IBM to develop the architecture, make some proof of concepts, and then finally set up the whole system. So we end up with a solution based on IBM Spectrum Scale, and this covers 2 nodes providing the capacity and 2 nodes providing the high I/O we need for the metadata and for the fast burst buffering capabilities. The core file system actually then serves as the final storage for data analysis, for the data shipment to tape and data exporting through a portal. This is all steered by the scientists themselves. So they have full control over which files goes to tape, which files goes to the portal. From the manifold features GPFS gives us, we use today a lot. It starts with the classical ILM feature where we use SSD-based storage as the tier 0 for the burst buffering and the tier 1 which is disk-based. We ship the data to the whole campus, to any Linux and any Windows machine through NFS or SMB from the core file system.
We had a storage system which basically locked the data into the beamline. The consequence of that was that users who came to measure their data at our facility didn't have access to the data until a few days after. There was a very high latency between when the data was taken and when the data was analyzed. You could, in fact, find out that the data is not what you wanted. It's not the quality you wanted, the parameters were not the right parameters. And the consequence of that is that you have to book more time at the facility further down the road and redo some of the work that you could have done before. So now that we have everything in place where within 4 minutes the data is already in the computer center on the core file system and can be turned over and analyzed by HPC resources, we can really provide the feedback that our users need. The ability to do that changes the whole way people can do research at our facility. It's day or night in terms of doing an experiment. You're flying blind or you're getting information back. If you're doing an experiment, it's what's in the data that counts. The scientists are extremely happy. The ability to provide their users with their data with very short timescales has changed the way that the experiments are done at the beamline and will continue to change how they're done. The possibilities are now much, much bigger and much more expansive.
When we start rebuilding and extending our accelerator and our photon source, we notice we definitely will run into a problem with the data management. And so we've looked for several solutions from several vendors. We've looked as well as for TCO. We've looked for the long-term strategy. And finally, we came up with the IBM solution based on the Spectrum Scale suite. For us, it was important to rely on a very competent team. And we have been very satisfied with what IBM offered. We think it will help us to solve our problems for the next 5 years.